SAP model. So first of all, we need to subdivide this long run rafter here into 7.8 segments. So we select the rafter and we go to edit. We go to edit lines, subdivide frames, and because we are doing this from initial point to the J point, so we're gonna choose divided at a specific distance from I end of a frame. The I stands for initial, that's the starting point of the frame, and the J, which is the end point of a frame. So we go to, because we need the absolute value, so we're going to say 7.8, and we go apply, we go okay. So this frame has been subdivided into this 7.8 segment, 7.8, yep, that's correct. So we can do the same thing for the rest of the rafter. We do the same thing, we go to edit, we can edit lines, divide frames, the same thing, 7.8 absolute. We'll click apply, okay. So here we go. We've got a second segment here. So we need to do the last bit because our wind is going to have a 2.14 wind down action on the apex value here. So we need to get we need to compensate another portion of the rafter and for that value. So to do that, we need to cut this member into how much we need to compensate for. So we need 17.5 minus 5.9 gives 11.6 meters. So we need to cut this member from 0 to 11.6 so we can make up this portion to this portion as a 7.8. So I hope that makes sense to you. So to do that, we need to find out what's the I value, what's the I end, it's either here or here. So to do this, we go to display options, we go frames, we go local axis, we click apply, yes, and we go OK. So these arrows indicating the I end and the J end. So the behind of the arrows is the starting point. That's the I end, stands for initial, and the towards the end, towards the arrow end is the J end, which is a joint. So we need to cut from the I end. So we go select the number, go edit lines, divide frames. We need absolute value of 11.6. We go apply, go OK. So this number has been divided into two segments, which is 11.6, and the rest of it, this number plus a bit of this number, that is 7.8. So this is the number we are going to apply a force of 2.14 kPa here. Sorry, kilonewton per meter. So this is pretty easy, and so next we just need to assign them. I'm pretty sure we all figured out how to assign the frame loads. Just go to distributed and go to wind, wind cross down, and remember it's always wind is always perpendicular to the member regardless of how the inclination is. So you've got local axis and it's pointing onto load direction is 2 x y z. Okay, the 2 is right, it's vertical direction, it's coming down, and the force is force. Okay, yep, sure, we'll just go for 0.54. 0.54. Interesting thing is some of the softwares they use negative 0.54 for wind uplift. So SAP is a bit different. So here we go apply. Yes, okay. See, so 0.54 is done. So we just need to do the same thing for the rest of the portions, and the wind load should be okay. So next thing is once we sort out all the loadings, we just need to go for design it. We can simply just push the button. You can run model analysis. Here we just run here, and takes about some time to run the analysis. Okay, the first, okay, the messages here, I'm not gonna deal with that later. Click done. So so the first mode shown here, the period is 1.5 seconds. It's a bit of a flexible because it is um, anticipated because the rafter in the across direction, it's got I reckon is the wind load is heavily influenced the dynamics of the structure, so it's wobble quite a bit, and you can probably see if you go swap here, go click the arrow left and right, it tells you second mode is 1.2. The further you go, the lower the modes are, so you can. And I reckon the lowest the periods would be in the longitudinal direction because the cross braces on the vertical cross braces on the both bay is helping with the lateral movement. But on the other hand, you can see on the left bay is only got one cross brace here. That means the one bay here versus two bay over here. The two bays obviously is taking twice as much load as this member here. So yeah, so the building I think is kind of a bit of in the longitudinal direction is probably exhibit some torsion because the stiffness is not evenly distributed through the frames. Okay, anyway, so we can go to view the results, and we can go for hang on, doesn't work somehow. Anyway, so we can do a design module. We can do quick design for the steel frame. We can start design. This is the checking the steel frame is whether they're designed or not. We can, as we can see, all the frames are red, which is no good. Don't know why, but we can figure out that later on. And we can go to display options. We can go for frame tendons. We can see what is the governing criteria for the design. We can choose envelope that tells you overall the worst case of the overall bending and moment and shear. So mostly portal frame is bending moment and the deflections, but for the ultimate limit state, which is the choose moment in 3-3, which is the moment in the major axis, you click apply. Okay, it tells you some of the information that's got heaps moment over here because in the lateral wind load is coming this way, so that column knee here is resisting most of the moment from the lateral action. And some funny things going on here. It doesn't have any moments here and any moments here, so we need to investigate what is going on here. And some of the canopies is showing some of the big moments, so that's something we need to investigate as well. It's a bit weird. Yeah, that's pretty much the overall. So, and if you want to see what is the value here, you can just click show value and show. It tells you what's the bending moment values here. And sometimes it's a bit of hard to see. You need to select some of the frames, just show them independently, and they go to exit direction, XY, YZ. Yeah. It's annoying. I don't like that much because it's not user friendly. Okay, here you can see some of the hockey moments in here and the column moments. That tells something about your design. The design moments is way too high for the capacity of the knees. So yeah, something needs to be refined. All right, this ends up the demonstration. So if you have any questions, you can make a comment below. Otherwise, I'll see you in the next video. Cheers.